talking about potential and kinetic energy. Think about them as this. Potential energy wants to move. It can't move, but it wants to. Kinetic energy moves. An example. Imagine a ball at the top of a hill. It's not moving, but it has a lot of potential energy. But when it starts rolling down the hill, it has a lot of kinetic energy. Still don't get it? Well, imagine I'm at the top of a slide. Gravity wants to pull me down, and that means I have like a lot of energy stored at the top. Like, you see, I'm not gonna go down, but I have a lot of energy, potential energy. But when I go down, all of that potential energy gets converted to movement energy, or kinetic energy, like this. Example 1, potential energy, kinetic energy. So example 2, potential energy, kinetic energy. Example 3, potential energy, kinetic energy. Now, let's do some maths. Hooray, so amazing. Now, potential energy equals the mass of our car times gravity, which is 9.8 meters a second, times 9.8 meters a second, or squared. So, that means it's an acceleration. So, because it's exponentially growing. And times the height of the thing it's falling. In this case, 1 meter. Now, height, mass of the car, 25 grams. If you put those all together, you get the potential energy. Now we've got the better bit, the kinetic energy, equals 1/2 times, that also can be 2 divided by, because 1/2 times halves it, mass times velocity, or velocity squared. You thought that was hard? Well, get ready for the real maths. So, potential energy equals kinetic energy, because when the car goes down, it has all that potential energy, and it all gets transferred into kinetic energy as it goes down. So, that makes our maths a lot easier, because now we know that, remember the formulas for potential energy, mass times gravity times height, and kinetic energy, 1/2 times mass times velocity? Well, we can now say mass times gravity times height equals 1/2 times mass times velocity. You remember those formulas? They're the formula from here. Because we know that potential energy equals kinetic, we've got all of those things which equal each other. And if we just plug in the numbers, we've got 25
grams
times 9.8 times 1 equals 1/2 times 25 times velocity times velocity. So, what we do is we work out what is half of 25, because 2 divided by 1/2 times. Well, that's 12.5, or 12.5. So we get, and what is 25 times 9.8 times 1, but times 1 doesn't. That is 245. Use a calculator for this. Then, using a bit of algebra, we get the 12.5 times, and we divide both sides by 12.5. So what that does, it gets rid of the 12.5 times, and you just need to divide 245 by 12.5. Well, lucky we have calculators. That is 19.6. And what it leaves left is 19.6 equals velocity squared. But, well,
need to square root the velocity.
Yeah, we need to square root the velocity, because what's that doing there?
You do it on a calculator.
Square root is divide. Well, you can just square root it on a calculator, and you get velocity equals 4.4 meters a second. Now we know the speed of the car.
Let's see if that's the real speed by looking at our footage.
Speedometer. We did some slow motion analysis of the car. And we came to a conclusion. It went 19 centimeters in 0.05 seconds. And we timed both 19 centimeters and 0.05 seconds timed by 20. And we got 3.48 meters in a second. And so, let's compare it to our original results. What? 4.4 meters a second? Why is that? Well, what about this? Friction. In a vacuum, we would be correct. But because of friction, we were incorrect. So that is annoying.